Namaste and very good morning to all. I, Dr. Mahesh Arvind, Chairman of Prajna Foundation, welcome you all for today's talk of the week, Prajna Prerana. On behalf of my team and behalf of the resource person also, I extend a warm welcome to all the audience. Today, the talk is on quantum computers, future computers. And the talk is by Professor Hemalatha. It's my pleasure to introduce her before she begins her talk. Professor Hemalatha is an associate professor in Vijaya College, RV Road, Basavanagudi, Bangalore. She is also coordinator for Infosys Springboard program. She is a coordinator for the Rotary International Desk 3190 Basavanagudi, Bangalore, as well a resource person for PU and high school teachers for DSERT. Professor Hemalatha has a passion for counseling students in career opportunities to cater to the needs of students for the industry as per the industry standards. She conducts outreach activities in educational institutions to disseminate information on Infosys Springboard in and around Bangalore. Madam also organizes educational outreach initiatives to promote understanding of quantum physics. She conducts free professional counseling for career planning and guidance, also for mentoring students with the goal of shaping a more positive and progressive society. She does counseling for students about the career opportunities in the field of science and technology. She also offers career guidance to students based on the latest developments in science and technology. So her research interests are quantum computation area, artificial intelligence area, and machine learning area. Over to Professor Vatsala for the talk. Madam, I once again welcome you for the talk.
A very good morning to one and all present, or rather each one of you who are present here. Shri Gurubhyo Namaha, Shri Ganeshaya Namaha, Jnananandamayam Devam Nirmalaspatikakritim Adharam Sarva Vidyanam Hayagrivam Upasmahe. I dedicate today's talk to Prajna Foundation, my parents, my teachers, and my well-wishers. I would like to greet you with a very good and bright morning to each one of you today, and I wish to introduce about quantum computers, which will be the future computers. My sincere thanks to Dr. Mahesh Arvind, who is the founder of Prajna Foundation, for giving me this opportunity. Thank you very much, sir. I try to do my level best and it is just a small introduction on this particular topic. According to IBM Research Center, scientists in a beginner's guide to quantum computing, they say that anybody can learn quantum computing, and thereafter hearing this particular talk, I think you will be motivated to learn more about quantum computing. Now, before talking about quantum computers, I would like to give a small introduction on what is called as classical computers. Today's computers are called as classical computers, which makes use of the transistor technology and complementary MOS technology, flash memory, and things like that. I'm talking about the hardware in the processor, or maybe even the memory part of it, the storage part of it. So they are called as classical computers, which makes use of the basic gates of electronics, which include AND, OR, NOT, XOR, XNOT, NAND, NOT, so on and so forth. So this is the technology that is used behind the building of the processor. It can be the AMD processor, or it can even be the the Intel computers. Now, these computers have a problem. Though they are doing their work very efficiently in today's field, it has entered everybody's house. As we all know that every device, in fact, makes use of this particular logical gates itself. Now, what happens here is that these gates are used for doing your calculations of addition, subtraction, and things like that. And of course, the computers have greater processing capabilities, which are capable of doing some alphanumeric computations as well. And we have built over, and we also have what is called as supercomputers, which are used in the scientific field, the military field, so on and so forth. The advancement, we have seen it ourselves in our day-to-day life, where Shubhanshu Shukla has gone to the space and stayed there almost for 14 days and has returned back to the Earth station. Not only that, with precision, we were able to target our enemy countries also. So great thanks to all the scientists and all the entire team of this electronic and technological world who have made these things possible for us, and we are able to have a better living. Now, coming to the quantum computing, as I said, anybody can learn this, and you can be motivated to learn more on this particular factor. Now, then the classical computers, again, they are helping us with also, not only with what all that I said, it has entered the field of even the farmers. The farmers' life is also being made more bright, making use of Internet of Things like the drones, where they try to sow the seeds or monitor the fields, and they do all these things with the help of the drones, which is an Internet of Things. Now, so the classical computers are the classical computers, and its wonderful powers is the capability of doing so many things to integrate and interface with Internet of Things, IoT, where we use different sensors. Sensors could be the cameras, or it can be the basically the cameras are used as sensors to design a device to help right from the farmers to the military soldiers, and also also to help the scientific applications. We make use of these things, these technology. Maybe it is even in the rockets that we use. So we should also talk about the classical computers today, because it's very important to know what is the technology behind today's computers. The next thing is about the quantum computers, which is the future trends. Now, we have some problems with classical computers. That is the very reason why we are going, there is a paradigm shift from classical computers to quantum computers. The thing is that we are not able to simulate many chemical reactions, molecular reactions with the help of classical computers. We are not able to achieve the required speed and precision of solving all the problems with the help of the classical computers. And that is one of the reasons why we are shifting towards what is called as quantum computers. So we should also understand that doing this, the classical computers are not able to do the simulations of the scientific problems related to physics or chemistry, and they are not able to do it at exponential rates, because many of the chemical reactions go at subatomic levels, therefore it becomes difficult for the regular computers to solve these problems. Now, quantum computers, we should understand what is quantum and what is computers. The two terms are put together. Quantum is a number. In simple layman terms, quantum means numbering. And computers, of course, we all know we use for computation. There's a difference, slight difference, subtle difference between computation and calculation. Calculation can be done with the help of calculators, and computation we need higher processing capabilities where we make use of the computers to solve. So this is a brief, a small introduction about what is the difference between computation and calculation. We should know that also. Quantum computing, so we are doing computation here. We are not using quantum calculators. We are using quantum computers to do some computing which where the classical computers fail. So therefore, quantum computing say that the quantum computers represent, excuse me, so after talking about the meaning of quantum and computers, we need to understand how quantum computing will help the society and things like that. Quantum computers represent a paradigm shift in computational power, fundamentally departing from classical binary logic. Instead of using 0 or 1, they use what is called as qubits. In classical computers, we called it as bits. Here we are calling it as qubits, which means quantum bits. So in quantum bits, we have, I will just give you a small example. We have, apart from the logic gates, we also have what is called as controlled NOT, Police gate, and control NOT, Police gate, and Hadamard gate. Yes, these are the different gates which are used as the basic processors there. I mean, they are the circuits that will be used there. So therefore, I reiterate that we use qubits here, which is the unit that can exist in superposition states, enabling them to solve certain problems exponentially faster. This capability has tremendous implication for fields such as cryptography, material science, machine learning, optimization, and beyond. Now, coming to the overview of the quantum computers, which are the future computing devices. The quantum computers are not merely faster than classical computers. They operate under quantum mechanics, leveraging principles like entanglement, superposition, and quantum tunneling. Please, my dear viewers, you need not have to fear listening to these things, because these terminologies may sound new to you, but however, when we try to understand them in detail, we can definitely approach and get what we want. While still in early development, advances in hardware, like we have the supercomputing qubits, trapped ions, topological qubits are made use in design and development. And with respect to software of what is the software that is being used in the quantum computers, it includes quantum algorithms and designing of quantum compilers. They are having some, they are giving some promise to us in future. So key global changes include error detection and correction, scalability and decoherence, and practical usability and cost are some of the main challenges that we are facing here. Now, coming back to the definition, where we said that we are leveraging the principles like entanglement, superposition, and quantum tunneling, I would like to give you a small introduction on what is this entanglement and superposition mean one by one. So the first thing is, what is entanglement? Entanglement is a fundamental concept in quantum physics where two or more particles become linked such that the state of one particle instantly influences the state of the others, regardless of the distance between them. Now, we can imagine something like this. Assume that you and your friend have two magical dice. You roll your dice in London and your friend rolls the dice in Tokyo. Please see the distance. Now one is in the complete east, the other one is the complete west. We know that, and they are far away. Whenever you roll a 6, they instantly get a 6. How do they get the same value is a question. Even though you are thousands of miles apart, there will be certain delay even with the help of maybe satellite communication, or it can be even your undersea cables and things like that. We make use of these things for communication purpose. Okay, so but quantum computers are able to get the same 6 at both the places. So this is the magic of the entanglement property in quantum computers. And this works every time, not just once, but every time, no matter how apart you people can be. So you can try it from even North Pole to South Pole also. So this is about entanglement, a small introduction, of course. Then when we talk about what is superpositioning, it is a core idea in quantum physics that says a quantum object like a qubit can be in multiple states at the same time until you measure it. I reiterate that qubit stands for quantum bits in the quantum computer, just like your bits in classical computers. So therefore, it can remain in different states, but once you try to measure them, it will be in one particular state. Now, I can quote an example like the source is Bangalore and you have to reach another place, Bangalore. So, your source is Bangalore, destination is Bangalore. Now, you can assume that Bangalore is 0, Bangalore is 1. Now, if you have to go from Bangalore to Mysore, in case of classical computer, it can be represented as 0 and 1. But in case of quantum computers, you can take all the places, every place gets counted. And ultimately, you try to measure, you will come to know to what percentage you have reached the destination. Mean to say, suppose, are you near to Dharmasthala? That means you are more closer to Bangalore. Suppose you are still in Tumkur, which says you are closer to Bangalore. So you are able to measure all the intermediate states also. So this is the power of superposition. Now, in classical computer, I reiterate, a bit is like a switch, light switch. It sets on or off. So on is represented as 1 and off is represented as 0. But in quantum computer, a qubit is like a magical dimmer switch. Another example I can quote, where you can change the intensity of the light, maybe brighter, 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 and things like that. So there you can apply this. It can be both in on and off, both in on and off state at the same time, and this is called superposition. Only when you check what is the position, it chooses one of the two, and this adds power to the quantum computers. So then, what is the phenomenon inside quantum tunneling? This is also one of the properties that we try to leverage. So quantum tunneling is a fantastic phenomenon from quantum physics where particles pass through energy barriers and they shouldn't be able to cross according to classical physics. In classical physics, if a particle like a ball doesn't have energy to climb over a hill, it just stops there. But in quantum mechanics, particles like electrons behave not only as particles but also like waves. So this is one of the properties, and I think even in our Upanishads we say that we have to always be positive. We need to think positively so that everything happens positively, which is a very optimistic approach towards life, and I strongly believe in that. So the particles behave like waves. So this wave nature is helping in making the particle to go and cross the barrier of this particular hill. This wave-like nature allows the particle of the wave to exist on the other side of the barrier even if it doesn't have enough energy to get over it. And this is called as tunneling. So I can also give you one more analogy. Imagine rolling a ball at a hill. In classical physics, if the ball doesn't have enough energy, it rolls back. In quantum mechanics, the ball has a chance to appear on the other side as if it tunneled through the hill. So this is about what are the different properties that is being used in quantum computers. Now, let us also have, we will see where this quantum tunneling is also used. That is also equally important here. One is in nuclear fusion in stars at the space. So, protons like stars, like sun, I am talking about sun is also a star. So, there, which tunnels through repulsive forces to fuse and release energy. This is one of the applications of quantum tunneling. Semiconductors and electronics. There, in that particular field, we have tunnel diodes and flash memory rely on quantum tunneling. Now, it is also used in devices like scanning tunneling microscopes. It is called scanning tunneling microscopes for imaging atoms. Then third is the radioactive decay, the third application, where alpha particles escape the nucleus via tunneling. And quantum computers operate under different quantum mechanics, as I told you, and I have given you enough examples to explain these particular aspects or the properties. Now, let us talk about the applications which I told that I will be talking. Now I continue with this applications of quantum computers, very important because we know that we are lacking in the simulation properties. We are not able to achieve the required levels in speed or maybe the precision also. So therefore we'll be able to see how these quantum computers help the human kind, the mankind. The quantum computers have the potential to revolutionize many fields by solving problems that are currently too complex or time consuming for the classical computers. Below are the key applications of quantum computers, both current, that is the present, and as well as the future. Now, the first example that I always love to quote is with respect to what is called as cryptography and cyber security. Dear viewers, we all know what we face in day-to-day life, like how the money is being just transferred from one's account to another's account, even without any intimation to us. And where we can now, at this juncture, I would like to say that we can increase the power of cyber security. So, as we are all aware of how these crimes happen nowadays, especially when we talk about somebody's money being so easily taken away. So, this kind of, with the help of maybe a mobile phone also, which is a very common factor. And how to avoid that is the question, and that we can get that particular aspect through what is called as breaking classical encryption. Now, the quantum computers can run Shor's algorithm. This is one of the algorithms to break RSA encryption. Now, RSA algorithms are currently being used. It is one of the widely used asymmetric encryption techniques. It is actually named after Ron Rivest, Adi Shamir, and Leonard Adleman, who were the professors at Massachusetts Institute of Technology. Now, this algorithm was groundbreaking because it introduced the concept of public key cryptography and things like that. Okay, we have what is called as public key, private key, which will be used to send the data, and that comes under communication and cyber network security. So it is used there. Then quantum safe encryption is possible, which leads to the development of post-quantum cryptography to defend against quantum attacks. It is not easy to attack a quantum processor. Now, maybe it is because of the hardware design, or it could also be due to the quantum algorithms. Separate algorithms are designed which will function on these quantum computers. Now, also we have what is called as the second application is drug discovery and molecular simulation. Here, the quantum computers can simulate molecules and chemical reactions at atomic level. This can be actually made use of. So it is used to discover new medicines faster, because in one of the videos which I saw, where they said that how there is an enzyme which causes pneumonia, and how they to study the patterns of these molecules, it's very difficult, and they need the help of quantum computers to resolve this particular problem. I'm just giving you a very brief idea because I'm not competent enough to talk about this particular aspect. And it is also used to improve material science which includes supercomputers and batteries. And the next application being optimization problems. Many industries are having lots of problems with millions of possible combinations, like supply chain logistics. We are we are aware of how supply chain is a very important aspect when we talk of moving a material from one place to another, or maybe what is the security involved, and how many people are required, and how to port them from one place to another, where quantum computers resolve this problem very easily. And airline routing, another problem. So we need to think of airline traffic also, which is very important, where we make use of quantum computers to do this routing. We also have financial portfolio optimization. I have a gut feeling that when we talk of the stock market, which is just, we are laundering inside the country, it can be made international, and where we can even purchase and sell the shares in the international market also. The days are not very far off. Now, the quantum the quantum algorithms like quantum approximate optimization algorithm, it is called as QAOA, can find better solutions much faster. Then, as I was talking, again coming back to the finance field, quantum computers can predict stock market trends more accurately and improve risk analysis and fraud detection. So, these are all some of the problems that we are coming across in today's computations or today's computers. So, also we can simulate complex financial models like option pricing. So this is another field where quantum computers can be used. Now, talking about artificial intelligence and machine learning, it can boost training speed of AI models. It can be more powerful to determine data pattern recognition. Pattern recognition finds, is a topic of its own. You can write a book on that, where we make use of statistical problems also, where we can make data analysis. It is very useful. Now, machine learning, for all we know, is a very simple concept. Let me tell you, whatever that I give the machine, maybe as a speech, making use of what is called as natural language processing, or you can type it as a text. We are giving it to a particular software. That software is taking my inputs as its own feedback. It is an experiential learning for the machine as well, and it is able to process and give lot of information. Amazon especially, the classical example is your Amazon, whatever you purchase. Now, it will study your patterns of purchasing, and it will give you it will also study how regularly you are making use of, how regularly you are purchasing these things, and it will give you what you like and what you don't like, and it will give you a lot of suggestions also. So therefore, quantum computers helps in decision making as well. And then quantum versions of algorithms like support vector machines, clustering, and neural networks are being developed currently. Now, neural networks is a wonderful field where we can really have. I mean, according to my knowledge, whatever my knowledge goes, I think there are millions and millions of neurons in the human body or the human brain, which is there is a total mapping of this like a network, and we call it as neural network, which is a subject of its own, where we can make use of quantum computers to find out what are the diseases, or maybe what is a problem, and why is a person very intelligent, and things like that. Then next comes the weather forecasting and climate modeling. Even here we can make use of quantum computing. Quantum computing could dramatically improve precision of weather predictions, modeling of long-term climate changes. So this is one of the greatest applications. Like, we are able to find out if there is a tsunami, maybe at a faster rate, or modeling of long-term climate, maybe what is going to happen after 1 year, what will be the climate that could be existing during that time, the climatic conditions. So the quantum computers help us determine all these things so that the mankind can be saved. Of course, I don't want to talk about the negative aspects of quantum computers. I'm only interested in giving you the positive aspects. Then it handles vast variables involved better than any classical computers. Then coming to material science and energy, uh, we are able to design new materials with better properties. For example, lighter aircrafts can be designed, lighter aircraft parts can be designed, which can also be durable and sturdy, which can, withstand all the worst conditions in the when it is flying, and during building materials. So we also need to think in terms of saving Mother Earth and sustainability towards the environment, the key factor. So I strongly believe in this, and improve battery. It also improves battery technologies like solar cells and green energy solutions. So the next application being aerospace and defense. Yeah, route optimization for aircrafts and drones. Drones is another new emerged technology already being used. Very recently, I could see one of the video clippings where the Indian postal department in Mumbai, they actually ported a parcel material from one region to another region within the radius of 5 kilometers in Mumbai, which just took 10 minutes for them, which could have taken perhaps hours together when they travel through road. But of course, we need to have stringent rules, and again, we should not increase the traffic in the space also, or rather above the earth. So that is an aspect, that is the another aspect that we need to be careful about. Then the second thing being secure communication using quantum key distribution. This is another aspect in defense, and quantum sensors for more accurate navigation and detection system. So we need to be, as I told you, quantum computers helps not only in speed but also in gaining the required precision. Not only aerospace, we can also think of space also. Then fundamental physics and chemistry, where we simulate quantum systems to better understand quantum field theory, black holes and Big Bang. Of course, the lot of research is already happening in these particular fields to understand what is a black hole, and the Big Bang theory also. And of course, Einstein has given us lot of inputs in this regard which can be made use of. Then also another application being to solve equations in quantum chemistry that are impossible for current computers to resolve. Then this is about the various applications. Maybe it is restricted to this right now. The days are not far when every house will have a quantum computer. So we have to think in these terms, and it is left to the future generation, the Gen Z people, to take it over and come up with quantum computers and bring put their ideologies to improve the science and technology, the current science and technology. Now, after this applications, it's a wonderful idea that we have all these applications. There are different computers also which is being used currently. Now, even before talking about the what is the limitations, I would also like to give you some real world examples of quantum computers which are currently used or which are under development as of 2025. So we have first example being IBM quantum systems. IBM has already developed one and they are doing a lot of research, of course. Example is IBM quantum system 1. It is called IBM quantum system 1, where the type of circuits or the processor makes use of superconducting qubits. Okay, so the notable features being cloud-based access via IBM quantum experience. The second application where they are using is roadmap towards 1000 plus qubits with error correction. So whatever the errors that the machines make, the system itself is able to do the first do the error detection and then the error correction. So it is used in chemistry simulations, financial models and quantum education. Then the second quantum computer is built by the Google. Google calls it as Google Quantum AI. Example is Sycamore processor. Okay, they use, again they are using superconducting qubits. So the milestone is they have achieved quantum supremacy in 2019 itself. by solving a problem faster than any classical computer. So their next project is scaling up to fault tolerant quantum computers. Fault tolerance is nothing but if any system fails, there has to be a backup system to take over and continue the process of computation. That's it. The next, again, it uses the use cases or where it is applied is in case of it is applied in physics simulation and optimization. There is another computer called quantum computer called IonQ. So this is, it makes use of the concept of trapped ion qubits. Okay, the advantage is that low coherence time, then room temperature operation. Now, I will also be telling about some of the challenges where I'll be covering this aspect. So, it is used in machine learning, logistics, and pharmaceutical simulation. There is another quantum computer called Baidu and Alibaba Quantum Labs in China. So, China is always, not to talk about a different country, but however, they are doing a lot of research in the field of science and technology, especially in computations, and developing a quantum computer, or maybe even in developing a classical computer or any devices, peripherals, designing and development and assembly is all done in the Chinese countries. So there is the China is already up with this particular computer, which is quantum computer, Baidu and Alibaba Quantum Labs. So they make use of photonic light. They make use of photonic lights. Now, what is the achievements is that the quantum advantage is specific sampling problems. Then competing with global leaders, they always try to compete, and of course, yes, we should not give up. And then the next application being D-wave systems. This is another computer. I'm sorry, it's not the application, but it is another quantum computer here. It is called D-wave systems. Example is that advantage of the type being used is quantum annealer. It is different from gate-based quantum computers. So it is good at solving optimization problems like traffic routing, logistics. Now, whenever we say supply chain management and logistics, always traffic routing is, they are two sides of a coin. Then we have 5,000 plus qubits, but not universal quantum computing. Of course, we have many other companies across the world, and I should also not forget to mention about Microsoft Azure Quantum, where they use simulators and partnership with quantum hardware providers like IonQ and Quantinum, it is called as. Okay, and the future goal is topological qubits, which is still under research. And Honeywell is also there, and so many different countries are already there. Now, talking about the last part, which is called as the challenges of quantum computers. So, quantum computers offer groundbreaking potential, but they are also facing major challenges that prevent them from being widely usable today. The first aspect being the cost of developing a quantum computer. It costs few crores to develop a quantum computer, and again, therefore, we cannot be every house property there. So, and one more thing is that the processor needs to be, the entire circuit needs to be maintained at 0 degree. To achieve 0 degree is another challenging problem that we need to look into and find a solution. Now, according to me, I feel that it has to be placed somewhere in the underground regions, maybe where we can get that 0 degree, or maybe at the polar, maybe North Pole and the South Pole, or space is a better place where we can place these processors. And how do we communicate? Of course, we have to make use of the laser beams for the purpose of communication, or any other improvised technology which can actually take the processing capability of these quantum computers. That is my maybe imagination, or maybe it will even come, it can even come true. So this is the thing. So I am also giving a solution. Now, there, coming back to the challenges, qubit stability is a big problem. Qubits are extremely fragile and lose their quantum state quickly due to interaction with environment. So what happens is it limits how long the computations can be carried out and things like that. So then next is quantum noise and errors. Quantum systems are very sensitive to small fluctuations in temperature, vibrations and electromagnetic fields. So the third drawback or the challenge is error correction is very complex. We need complex algorithms. We need to evolve with complex algorithms to resolve these error detection and correction problems. With the help, of course, we cannot forget that we are making use of qubits here. Then the next challenge being extreme operating conditions. Most quantum computers, especially IBM and Google, need to operate at near absolute zero, which is minus 273 degree centigrade, in specialized refrigerators. Again, we need to think of the for the placing these installing the refrigerators and placing the quantum computers there. Then scalability, it's too difficult to add more qubits without increasing errors and decoherence. So of course, we have limited algorithms and softwares to handle these quantum computers. We may develop the hardware, but we should also think of the software aspect. Then security implications is powerful. Quantum computers could break current encryption methods. That's another possibility. So there are many other challenges, but however, I am really grateful to each one of you for giving me a patient hearing on this particular topic of quantum computers. In the limited time, I'm able to, I don't say it is limited, I had sufficient time and I was able to convey whatever that I wanted to do so in this particular talk. So I immensely thank Dr. Mahesh Arvind for this. Thank you so much, sir.
Thank you very much, madam. Madam Hemalatha, in her talk, has provided enough information on classical computers, supercomputers, and so on, their advancement and applications, how they are helping the common man, especially farmers and military forces. You have also mentioned about the limitations of classical computers, and thus there was a shift from classical computers to quantum computers. So you have defined quantum computer and how they operate under quantum mechanics. And you have talked about the advances in hardware and how the promise to us in future that has been highlighted. Also the factors which power quantum computers, the different properties being used in quantum computers. And finally, when she talked about the applications of quantum computers, how they are helpful in cryptography, cybersecurity, drug discovery, neural network, climate modeling, and so on. So she has added enough applications, the usage of quantum computers. And madam, you have quoted with real world examples. And finally, you have kept before us the challenges And this talk was quite informative, motivational for the students to add their ideas for further development in this area. So I thank you again. And if there are any questions, any queries, you can raise it in the chat box. Welcome to live chat. Madam is there to answer you. Any questions, queries from the audience? If not, now you can raise it. Whatever questions you have, whatever you want to know in the aspects which have been talked upon today, you can send the questions to us. We'll forward it to Professor Hemalatha. She will try to answer it. Definitely. You can mail us also to Prajna Foundation. That will be forwarded. Okay, with this, we'll conclude this session. From Prajna team, from all the members of our foundation, and on my own behalf, I thank Professor Hemalatha for this informative lecture on the talk.
Thank you very much, sir. And my sincere thanks for giving me this particular opportunity. And I also thank each one of the viewers for giving this patient hearing. Thank you very much.
Thank you all.